So I want everybody to read the problem first, the first problem. Don't read the steps yet, just read the problem. Okay, so we're trying to fence something, and we want that fencing, so we have an exact limited amount of fencing, and we want to fence the largest possible area. So step 1 says identify what the question is asking you to find. It's asking you to find the largest possible area. It's usually the last sentence, and it is the last sentence in this case. Okay. So and then read the question carefully to set this up as an equation. So the largest area is what you're trying to optimize. So let's call that area A. And it has to be a function of something. Okay, so we have to declare this input value too. And we can get that input value by first drawing the picture of what's going on here. We have a rectangular fence, and there's a river on one side. Okay, rectangular fence. So we have to describe the dimensions of this fencing. So let's call this X and call this Y. This will also be X then. So basically we let X be the length of fencing, and Y is the width. Okay. Now, right now, that means area is X times Y. Okay. Now, this is a problem because my area is not a function of one variable but two. Okay, so we're gonna have to put some effort into turning this into a one variable equation. Okay, so we also know, so this is step 4 right now. Okay, so actually write down all possible equations. So this is one equation. The other one is that 2x plus y, this is the representation of the sum of all the fencing, is given. It's 2400. So this is step 3. Write down all possible equations. Using these two equations, you have to make sure what you want to optimize is function of one variable. So this is what you want to optimize. It has to be in terms of one variable. And from here, you can replace the y with just x. Okay, let's call that equation 1 and call this equation 2. Equation 1 sub into equation 2. So you get x minus 2x. Okay, now we're happy because area is a function of just x. Okay, so this is essentially like y is equal to this equation here, and we know how to optimize this. Okay. Now, before I actually start doing it, there are endpoints. Remember I talked about how this is related to like the graph analysis. What are the endpoints? Is there a restriction for x? 0. Yeah, of course there is. 0 to at most it's got to be less than the 2400, right? So there is restriction. Okay, now let's differentiate the a as a function of x. I don't need to expand it. I can just do product rule, right? Well, there's 2x, so actually, so you're right. This should be less than 1200. Okay. So let me continue with differentiation. Plus x times minus 2. So we get 2400 minus 4x. Right? If you set that equal to 0, that'll tell you the local max or minimum. Okay, so x is going to be 600. So this is, actually from here, I know this is a parabola that's going downwards, right? Because of if you times by x with minus 2x, you get a negative 2x squared. So I know this is going to give you a maximum value. Right? I can further consider the endpoints, but because it's a parabola, I know this will be the maximal solution. Is that right? Okay. Therefore, max area is 600, right? And from here we can find y. Okay, so let's do 600 times by 2400 minus 1200. So 600 times by 1200. So that's the maximum area that can be enclosed. Okay, so we actually always have to say, therefore the maximum, you gotta have a concluding statement. Maximum area that can be enclosed is this.